back to the channel. So in the last session we see that how the programming language works actually, and what is a programming language, what are the advantages of the programming language. Now this time we'll be starting our journey with the Java programming. Prior to that, we need to see what is the roadmap, the sequence that we are going to follow as a part of this Java journey. So let's see. So we'll be going to the introduction of the Java, that is a basic what is the Java and what are its different features. Then what is the platform independence of Java, and JVM, JRE, and JDK. Then we'll be looking into how to set up the environment for the Java. So mostly in Windows and Mac we can download the executable, and we can do the installation of the Java. That we'll see in this session. Then we'll be going through the Java syntax, that the fundamental syntax and the structure of a Java program. We'll be writing a simple program in Java like hello world, and we'll try to understand what are the different components or the methods that has been the part of the program, just as an introduction point. What are the comments, how to do a single line comment, how to do a multi-line comment in the Java, and what are the identifiers and keywords in Java. Then we'll be going to the variables and data types, that how to store and manipulate different types of data in Java. So mostly we'll be going through the primitive types, reference type, then we'll be looking at some type conversion, then we'll be going through maybe array as a basic, then string. Then we'll be looking into the operators, like how to perform the operation on variables and the values. So we'll see some arithmetic and logical operators mostly. Then we'll be starting with one of the important flow, that is the control flow, the if-else statement, then switch statement, the for loop, while loop, do while loop, and the role of break and continue, how to use them effectively during our programming as well. Then we will be looking at one of the most interesting stuff of Java, that is the object-oriented programming. So this will be the heart of the Java programming, we can say, the classes and object and constructor, then method, then access modifier, then encapsulation. Then we will be going through the concept of inheritance and polymorphism, that how to build class hierarchy and create flexible reusable code. So we will be doing both practical, and we will be implementing live while going through the theory. Then we will be looking for the abstraction and interfaces and how to use them, especially in case of the test automation, how to utilize all these OOP concept. We will have a look by writing a simple script. Then we'll see the exception handling, what is the role of exception handling, how to use it in our Java program. So try catch block, then multiple catch blocks, then finally block, then throw, and where to use throws, then custom exception, that is defining the exception on our own. Then we'll be going through the essential data structure, which is built in and provided by Java, that is the collection framework, at the list, set, map, queues, iterators, and comparators. We'll try to solve some problem around that area as well. Then we'll be looking into the file input output. So mostly this will be very much useful during our OOP automation framework implementation, whether it will be the OOP concept and collection framework, then conditional, then file input and output, that how to read from external file, okay, then how to write into file, then how to create different type of HTML report or whatever so report that we want to create. So we have to take the help of file input output. Then we'll try to understand the concept of multi-threading. That is nothing but like how to use the concurrent programming. That means how to achieve the thing faster in multiple threads. So we'll try to see the executor framework there. Then we'll going through the synchronization and different threads. Then at the end we'll be going through the Java 8 feature, that the lambda expression, the stream API, the functional interfaces. So the default method provided by the Java 8 that will reduce the lengthy code by using the Java 8. So we'll be covering all these stuff in our Java series. The features of Java. So when we are talking about Java, so each feature is going to come to our mind. First will be the object-oriented programming. Second one will be the security and the robustness. Third one will be the platform independent. Then fourth one will be the automatic memory management. And again, the last one, there is large community and support. Now let's try to compare the Java with C++, like what are the features as compared to C++. Now the very first term that comes in Java as compared to C++ is the memory management. Java is having an automatic memory management, where in C++ we have to manage it by a programmer. That means in Java it gives you an advantage that you don't need to care for the memory management. Let's see with a example for the same. So if you see that what is the memory management, it is nothing but how programs allocate and free memory resources. When we create the variables or object, our program needs memory to store them. Now how the memory is being handled, that differs significantly between Java, C++ and Java. So in C++, it's the responsibility of the developer for manually managing the memory, while Java handles the memory management automatically through the process known as garbage collection. Let's see here how it works. So if I go ahead and see the left side, you can see there is a program written in the C++, and in the right side there is a program written in Java. So it's the same program, a class person, okay, and it's written in both of the programming language. And if you see here, right, memory, we know, as we know, there will be memory, which is the stack and the heap. So stack is nothing but the fast and limited memory which stores the local variables, function calls and references. However, heap, when we talk about the heap, it is the larger and more flexible memory area for the dynamic allocation. Now when I go the next, like writing, I'm just creating the object, okay, the instance for the C++, okay, and you can see I'm creating the heap person as well with the person pointer, then heap person equal new person. In case of Java, if you see here, right, in the left side you see you have created the stack person and heap person, but in the case of the Java you have created like person 1 and person 2. So both of the person 1 and person 2 will be created, the variables will be created in the stack and they will be referred to the heap memory. So in case of C++, what happens once your programming is completed, the developer will be responsible to clear the memory for the heap area. However, in case of Java, it runs garbage collector automatically that manages the memory. So it helps like preventing the common bug like memory leak. Okay, hope you are clear about the memory management and how it's work in case of both C++ and Java. So the advantage is that Java is having the automatic memory management process. Now let's go to the next point, which is nothing but the platform independence. So what is the platform independence? That you have to write it once and run it anywhere. So let's see an example. One of the, we'll see the C program as well as the Java program. Okay, so you see, like we have written the program, the hello.c. Similarly, we have written in case of the Java as hello world, just Java as a source code. Now we'll be compiling with the C compiler and the Java compiler. So here the machine code will be created, the hello.exe, and here in this class the bytecode is created by the Java. Okay. Now when we see about how to run the code and all, this bytecode that is independent of the platform. Okay, so if you see, we are placing the code in the different platform, Windows, Mac, okay, Linux and Android. So when we try to run the program, okay, so if we run the C program, it will be running on the platform upon which it is compiled. So it has compiled on the Windows platform, so it is going to run on the Windows platform, and it is going to fail on the other three areas. But if you see, the Java program is being run across all the platforms. So when we install the JVM for the respective platforms and we run the code what is written here, the bytecode, when we try to pass it, so it is going to run it. So that is the concept of the platform independence, that we have to write the code once and it is going to run across all the different platforms, making it as a platform independent. Looking at the other features like pointers and multiple inheritance and performance, we can say the C++ will be faster very much compared to the Java, and just the development speed is little bit faster in Java as compared to C++ because it has kind of more complex debugging. Now let's before going more detail into Java, let's understand the concept of the JVM, JDK and the JRE. Now prior to that, you can see a diagram here. So just imagine the very first one is your JDK, okay, that is the Java development kit, which will be having the JRE, and JRE will be having the JVM. So let's see the feature. Mostly just remember that JDK is needed for the development purpose, and JRE is needed to run the Java program. Okay, so if you see here, like you can see the more details here, that in the JDK will be having the Java C, the compiler, okay, the main part, and in the JRE, that is the Java runtime environment, so which is required for running Java application. The first one is for the building the environment, okay, second one is for the running that application. Okay, so it will be having some class libraries and it will include the JVM, okay, which is nothing but the Java virtual machine. So let's see little bit more in detail. So we see the three pillars of the Java, that is nothing but one is the JDK, then JRE and JVM. If we look more into detail, okay, so it's JDK is kind of the software development kit that is used for the Java application. Like we discussed, it is having the Java compiler to convert the Java code into the bytecode. So it will be having the development tools like debugger, Javadoc and many more. It also includes the JRE. So we'll see it in action in some time. Okay, now let's go. Okay, one of the points that I will need to highlight, that it is needed by the developers, not by the end user who just run the Java application. Okay, now when we go for the JRE, okay, it provides the library, okay, and it includes the JVM that executes the bytecode. So if you remember, with the help of the JDK, we are generating the bytecode, okay, and when this bytecode is passed to this JRE, okay, and it is having the JVM internally which executes that bytecode and display the program output for us. Okay, so let's go and see the more details about the JVM. So it's kind of the internal mechanism, you can say. It loads, verifies and executes the Java bytecode. Okay, and it is platform specific, like it will be different JVM for the Windows, Mac, Linux, like we see before in the platform independent case, right? We have created the java.class file, and when we are running it into the different machine, it was getting executed successfully. So in this case, we have to install the different JVM for the corresponding platform, and then it will be getting executed. So if we see here, the differences mostly what we see that JDK for development, JRE for running application, and JVM for executing the bytecode. Includes the compiler. We see the JDK is having the compiler, then JRE it is having no, and JVM also no. Okay, so these are the stuff that we already discussed. Okay, who needs it? So JDK is for the developer, JRE for the end users, and JVM is completely internal component for the execution. Let's see the demonstration here. Okay, so if you see, this is my program. Okay, so if you see the JDK process here, so this is my simple program. Okay, so what does it do? When we write the Java C compiler, convert the .java to .class file. Okay, and this class file is platform independent. Let's see into action as well. So if you see here, I have already created a Java file. So if you can see here, this is class first program. Okay, the class name we'll see in detail when we go more into detail, and it is a simple Java program which is writing system.out.println that hello world. That means we want to see the message hello world for this. Okay, now when I compile this, and one thing you need to see here, that only the .java file is there. Okay, so when I'm compiling this, let's compile it. I'm using Java C here. Okay, I can see another file, first program that class has been generated, that we observe before some time. Okay, so what does this Java C compiler does? It converts .java file to converts to a .class file, which is the bytecode. Then the role of JRE happens. Okay, so what it does, it takes this hello world .class file. Okay, and when we try to run the application, it will execute that code. Okay, so let's try to execute our code as well. We see this class file is generated. Now I can say for program. Okay, then I can say it is getting printed the desired output. Okay, now since I have told that JDK is required for the development purpose, you can see I have downloaded JDK for version 17, and I'll show you how to install in your respective machine in an animated way after this session. Okay, I think now pretty much clear that what is the role of JDK, then how the JDK process. So from JDK generates the bytecode, and then JRE takes it and generates the output.